Here are the grade boundaries for Specialist Maths Exam 1 since 2016, 2023. How to interpret this out of 40 marks. The minimum needed to get an A+, last year was 37. The year before it was even higher, so it looks like 37.5 or 38. Whereas a few years ago it was a little bit lower, just over 35. In order to get an A+. A+, to give you an idea, is the top 9 or 10% of students. Generally, if you're getting 3 A+, you're probably going to be getting a 40 plus in your raw studies score. A is like the top 20% of students. 3 A's get you a high 30s. A B is around the median. So if you want to get a raw 30 in specialist maths, you need to be getting around 3 B's for your SACS exam 1 and exam 2. Last year to get a B, you need about 26 marks out of 40. Sometimes it's higher or lower, and that's the point of these graphs, is to see. Look at 2017. It's sort of the standout there for having the lowest grade cutoff. So meaning that was a particularly difficult exam 1. Not so much at the high end, so the A+ cutoff was slightly lower, but particularly at the lower end, in order to get a C or a C+, the grade boundaries are so much lower than in other years. If we look at the exam 2 now, so obviously we're out of 80 marks. Last year to get an A+, just under 70, it looks like 69.5 would be enough to get you an A+. And the standout there is probably 2021. So look, all the grade boundaries are lower, especially that A+ cutoff. So in order to get an A+ in 2021, 60 marks would have got you an A+. That's 60 out of 80. Whereas in other years, it's generally, around 70 or even higher. So we'll have a look at, this exam 2, 2021 exam 2. We'll have a look at 2017 exam 1. But before we do, maybe if we have a look at some of the grade distributions for the other subjects. So I generated these, using Python, get the data from the grade distributions for a lot of different subjects. But I guess if we have a look at, some of the math subjects first, so general mathematics, to get an A+, you need to be sort of, above 35. These are likely to go up this year because, as we know, all these exams had 5 multi-choice options, whereas this year you're only going to have 4. So expecting, these lower cutoffs are going to be a little bit higher, because if you're just randomly guessing out of 40 marks with 5 questions, you're probably likely to get 1 in 5 correct. It's 8 out of 40. Whereas if it's 1 in 4, you're likely to guess 10 out of 40 correct. So these lower cutoffs will probably be, a mark or 2 higher, whereas the AA+ cutoffs may not change at all, but they may go up a little bit. General Maths Exam 2, again, relatively consistent over the year. So 2021 looked like a little bit harder, with the A+ cutoff being below 50 marks. 2022 being slightly easier. Methods, the A+ cutoff was a bit higher last year, so generally to get an A+, 34, even 30, as low as 33 has gotten you an A+ out of 40. But last year was more like, looks like 36.5 or 37 to get an A+. To get a B, so raw 30 in maths methods, roughly you're looking at around 20 marks out of 40. So that's about half the marks to get it to raw 30. Methods exam 2. So to get an A+ last year, the grade cutoffs were lower. Into getting last year's exam was quite difficult relatively. But I guess when we compare to 2022, it's actually slightly easier. So perhaps, the difference between last year's exam and the year before surprised some students, whereas the A+ cutoff was almost 70 in 2022, was just over 60 in 2023. You can look through more of these later on if you like. So biology, chemistry, physics A+ cutoffs are quite high. That exam is out of 130. Psychology is out of 120. This is quite an interesting one. So English language, the A+ cutoff since 2021 was, this is out of 75, around 60, and then sort of really decreased last year to just over 50. And all these, between the C and the A+ is really, which is like between the top 10 percentile to like the bottom. A C, I think, is like the lower quartile, about 25% of students below that. Maybe before we look at some actual maths questions, I'll just look at one more chart, which is the chart showing out of all the different subjects, the number of students who took each subject. So here we are, English, obviously the most popular, almost 40,000 students sitting English, followed by general maths, followed by psychology, then methods. Bio and Biz and health are sort of quite similar on about 14,000. Get down to specialist maths. So I tend to think of specialist maths like quite a small, niche subject, but actually compared to a lot of other subjects, there's more students, more than EAL, more than global politics, This is the most popular LOT with only 1,500 students. There's so many different subjects available, but a lot of them are LOTs, languages. So we get down to like Persian, Arabic, 100 students, Auslan, Serbian, very few students actually sitting those exams. So this is the 2021 exam 2, that very, very difficult exam 2. We'll look at some of the more interesting or more difficult questions. The first few multi-choice were okay, but as soon as we get to about question 4, this complex numbers question only had a 35% success rate. So we can have a look at this one. Z is a complex number, imaginary Z. Z is a complex number, imaginary Z is greater than 0. And we want to find the angle of this complex number here. With the CAS calculator, we can make this a lot easier by doing define Z equals X plus YI. So define Z equals X plus YI. And this can be useful in a lot of complex numbers questions, particularly multi-choice. We want to find the argument. So on the Inspire, argument is angle. It is there under the complex number menu as well. Menu number, complex number tools, polar angle. And we can pretty much type this in. We also have a conjugate function on the CAS calculator. So Z times conjugate of Z, again, that's under the complex number menu. And then Z minus conjugate of Z. And that would simplify down our expression in terms of X and Y. This sine of Y thing depends obviously on the sine of Y. We're told actually imaginary Z is greater than 0. So if we tell the CAS that, given that Y is greater than 0, it would simplify that immediately. Sine of Y would be 1, and this becomes negative pi on 2. So bit of clever CAS calculator use there. And the next one, so 4, 5, and 6 were all complex numbers questions and all, quite difficult and done very poorly. But let's have a look at this one. So we've got this graph here, which is a circle. We want the maximum value of the modulus of Z, so the distance of Z from the origin. And actually the easiest way to do this one is sort of geometrically. So from the origin to a point on the circle, that's going to be the closest point here. And we can see that the furthest point is going to be this one over here. So we can just use a Pythagoras theorem there to find that distance. We know where the center is going to be. It's going to be at 2, root 3. This one here, was quite tricky as well. We know that Z squared is a real number and we're trying to find the possible values of the argument of Z. I've actually explained this question in another video, so I'll probably just link to that, but definitely using polar form and drawing up a diagram with the keys to that question. This one is quite an interesting question. Which one of the following derivatives corresponds to a graph of f that has no points of inflection? And yeah, so these are derivative graphs. We want to find for which of these derivatives would the original graph not have a point of inflection. So this is a parabola. If the derivative is a parabola, the original graph f is going to be a cubic. Well, a cubic is always going to have a point of inflection. Doesn't have to be a stationary point of inflection, but any type of cubic is definitely going to have a point of inflection. So you can rule out A, can rule out C and D. We're down to B and E, which are both cubics. The derivative is a cubic. The original graph f would be a quartic. Now, quartic does not always have a point of inflection, so we could check for both of those. When we anti-diff, maybe sketch it. So that's the derivative graph. The original graph is going to be a quartic, so we could integrate that. We will get this bracket to the power of 4 divided by 4 plus 5x plus c. It's not showing there in the window. Okay, so there it is. So we can see this quartic graph here does not have any points of inflection. This statistics question only had a 50% hit rate. Actually, question 20 was also statistics and was even worse done. So this one, 2 coffee machines are independent of each other. The time taken to produce each one is normally distributed, and we want to find the probability the time taken by each machine to produce 1 cup of coffee will differ by less than 3 seconds. So the idea with this one, if you want to find the difference to be less than something, so we've got normal variable x, say, and y for the 2 coffee machines. In this case, they're going to have the same mean and standard deviation. But then the difference, we don't know, is that x minus y or y minus x. So depending on whether one is greater or less. So we can just set x minus y, for example, to be between -3 and +3. And then on the CAS calculator, normal CDF probably get you there. All right, so onto the extended response, and yeah, there was some really hard questions on the extended response. It starts off okay with this rational function. Just asked to rearrange it, state the equations of the asymptotes. Then in part C, we're asked to actually sketch it, and this was not really well done. Like out of 3 marks, the average was 1.5. And a key error they said in the assessor's report was students were just not changing their window and missing out a whole section of the graph. So key point is if you've got a grid there, which often you do in your exam, then set your CAS window to the same as the grid. So here x from -10 to 10, y from -5 to 15, and then you won't miss out part of the graph. These questions here are part D, 1 and 2. They sort of generalize the function which we had, replace one of the numbers with a k, and then ask for what values of k will the graph have, 2 asymptotes, and then no stationary points. It's quite a nice question, but it does depend on having a good understanding of the graph. So if you've messed up the previous one, probably you're going to struggle on these ones. But quite a nice question if you have a go at those. Next question was a complex numbers question. A little bit different though from our standard complex numbers question. I mean, we're not really given much about this polynomial. We've got alpha, beta, and gamma in this form. And then we've got this form with Z1, Z2, and Z3. So, I mean, from this factorized form, we can tell Z1, Z2, Z3 are going to be the roots. I'm told that Z1 is real and Z2, 3 are complex. We're also told the coefficients are real up here. So conjugate root theorem is going to apply. And the idea with A1 is that Z2 and Z3 are going to be complex conjugates of each other. I think, however, though, if they're all real numbers, then they don't have to be conjugates of each other. But it'd be interesting to see what the solutions say about that. But I think the idea is that those two are going to be conjugates of each other. Part 2, A2 is kind of interesting. So determine the values of these coefficients now, given some information here. And like this information is kind of confusing. Like the modulus of Z2 plus Z3 is 0, and then the modulus of Z2 minus Z3 is equal to 6. P2 is -13. That's okay. So we can sub that into the equation there. What's going on with these conditions? So I think it helps to draw a diagram actually for this one. So assuming Z2 and Z3 are conjugates of each other, well, this is saying the distance between them is 6. So if we've got 2 conjugates, the difference between them is 6. Well, that tells you that one of them is 3 above the axis and the other one is 3 below the axis. And this condition here, Z2 plus Z3 is equal to 0. Well, if we add 2 complex numbers together and get its modulus is 0, well, that means they must be equally spaced around the origin. So that condition tells us, the real part of those must be 0. If they're conjugates of each other and the real part was not 0, when we add them together, then we're not going to get a modulus of 0 there. Second part of that question was this sketching array. So again, just under 50% there, so students found that a little bit difficult, but I guess it's quite standard. And then we've got this thing about the ray intersecting the circle. So we've had that on several past exams. And then finding the area of the minor segment using the segment formula, which is on the formula sheet. I tend to ask it quite a bit, but not that well done here. I guess you have to have an accurate diagram of the ray and the circle in order to be able to do that question. The next question was this solids of revolution one. And again, this had some quite tricky parts. It starts off reasonably straightforward with a cubic, y equals x cubed minus 8, rotating about the y-axis. And this question here was, where it started to get really tricky. This one had an average of 0.3 out of 1, so this related rates question. And then the next part of the question, which was the last part, was even worse done. This is out of 3, average was 0.5. So we can see, it's quite wordy. I won't go over this one, but we'd have to sort of work through the whole thing from the start, really understand with a clear diagram in order to be able to solve something like this. And the next question was even worse, actually. I remember this question, I remember reading this question, when my students were doing the exam a few years ago and thinking, this was quite confusing. So I've got this very wordy thing about this car on a track. Okay, at least we've got a nice diagram here. Part A is okay. Part B, it starts to get a bit tricky. So this average 0.9 out of 2 for this question. And part C, average 0.4 out of 3. And it just keeps on getting worse. The next part, average 0.8 out of 2. And then the last question, I remember being confused about this reading it. I'm not going to go through it now, but out of 3 marks, the average was 0.2. So this whole question about this race car was really quite difficult to interpret. Anyway, won't go over that right now. And then the last question is the probability and statistics question out of 10 marks. Even the first one, its average is 0.4 out of 2. This one we could probably go over. So we have maximum load of a lift in a chocolates company is 1,000 kilograms. The masses of the employees are normally distributed. Mean is 75, standard deviation 8, and there are n employees in the lift. What is the maximum possible value of n for there to be less than a 1% chance the lift exceeding the maximum load? So there's already quite a bit of reading there, but what we want to do is set up a random variable for the weight of one employee. So it's going to be normal with a mean of 75, standard deviation 8. And now think about n employees, and we have formulas where we can get the mean of the random variable for n employees and the standard deviation for n employees. Once we have that, okay, well, actually inverse normal, because we want there to be less than a 1% chance that the lift is going to, that these n people are going to exceed 1,000 kilograms. So we can set that up using an inverse normal on the CAS calculator. And then, the next part of that question was poorly done as well. So out of 2 marks, 0.5 average. And again, we can see it's very wordy. So Claire likes having a hot drink, but she's got a meeting between 9 a.m. It's 8:52. She's fourth in the queue. It just takes a lot to process all these words, and that's, I think, what students have found difficult. It finished off with some hypothesis testing and this type 2 error. These questions are quite common to ask about, like a type 2 error, the chance of a type 2 error occurring. So I've done a video on that one as well. I think I explained that quite clearly in that other video, so you can have a look there and maybe come back and have a go at these questions. So this is the 2017 exam 1. As we saw, quite difficult. I've put the percentages in here from the assessor report. So on the first question, implicit differentiation question, that one was reasonably well done, average 2.1 out of 3. But a second question, this integral, out of 4 marks, average is only 1.9, so that's less than 50%, with 38% of students actually getting 0. I think probably with that question, this is a partial fractions question. You've got to split up your denominator. We've also got a 1 plus x squared, which cannot be factorized. So what we need for the partial fractions is like a over x plus bx plus c over 1 plus x squared. If you didn't choose that correct form, probably that's where those students are getting 0. If we do choose the correct form, go through with that partial fractions, do the integral, you're probably okay. This statistics question was not well done. Volume of soft drink dispensed by machine is normal. Mean 298, standard deviation 3. We've got pack of 4 bottles. We want to find the probability that the mean volume in a 4-bottle pack is less than 295. So we want to know the mean and standard deviation for x bar. We know it's going to be normally distributed. The mean of x bar is just going to be mu, which is, in this case, 298. The standard deviation of x bar is going to be sigma over root n. So in that case, it's going to be 3 over the square root of the sample size, which is 4. So we've got reasonably nice numbers there. 295 is going to be exactly 2 standard deviations less than the mean. So we're going to be able to work this out without the CAS calculator, because obviously this is exam 1. Next is vectors question. So 4 marks, again, average less than 50%. And all it is the angle between vectors. I think maybe drawing a diagram is the key here, because we want to find angle BCD. We've got some vectors, BC. These are position vectors. So let's just draw it up. Roughly, we've got an origin. We've got some points B, C, and D. And these vectors here are going to be vectors B, C, and D. These are position vectors. What we want is to find the angle BCD. Well, that's this angle here. So that then we can work out which vectors we're actually interested in. Vector CB is going to be B minus C. And CD, D minus C. Probably the students, who got 0 have used the wrong vectors in order to work out, we're going to need a scalar product here, but maybe they've chosen the wrong vectors. done angle maybe CBD or something different. This one is just a derivative question, but it's 1 over the arc sine of x. We want to find f dash of x. Again, average is less than 50% there. I think the key there was writing this 1 over arc sine as arc sine of x to the power of -1. Maybe it's confusing because like arc sine, sometimes arc sine, we write as, you know, sine with a little -1 there, and we've got this little -1 here, but this is a reciprocal. So if we want to differentiate that, we're going to use a chain rule. We also had to do the domain there, so that's, you know, going to take a little bit of thinking about where is this going to be defined. This question, I didn't like this question. So we've got a slope field, and we've actually got to sketch the solution curve. So it's always going to be difficult to do something like this by hand. We're told y of -1 is equal to 1. So we can start off, say, here. And then we've got to trace this curve, which is not allowed to cross any of these slopes. It's got to go sort of between them. So, but you know, as soon as you probably cross over one, you're going to lose a mark there. And this is the last question. Obviously, this is going to be harder. That's expected. Average here 1.4 out of 4. Let's just show that. So show this derivative is this, and then obviously that's going to be useful later on because in the last question we're doing a volume. When we rotate this curve around the x-axis, pi y squared dx. This is y, so y squared, we're just going to get arc cos there. We're told between x is -2 and y is equal to 0. So we also need to find, well, when is y going to be equal to 0 here? That's last question. We expect something a bit more difficult. It's probably the questions earlier on that have made this exam one of the more difficult and having those lower grade boundary cutoffs, especially at the lower end.